In this exercise, I'm going to teach you a formula that we can use to predict all kinds of things in the business. We can predict what our profits will be. We can predict, well, every element of this equation that I'm going to show you. Before I show you the equation we're going to use, let me give you some background. In algebra, we used the coordinate plane to plot data. Now you could draw a line through that data, and that looks like our total cost line. That's how accountants would use this. They'd plot their cost data over 12 months or a few years, and then they would figure out what's the fixed and the variable components of their cost. This is the fixed component, the y-intercept, and the slope of the line is the variable cost. So fixed cost and variable cost. Total cost is fixed cost plus variable cost. Now, in algebra, that's all we do is draw lines. And what is that good for? Well, for accounting, it's good to show the fixed and variable costs of a business. Now, the fixed and variable costs, or this line, could be shown as a picture of a line. That's a graphical depiction. Or it could be shown as a formula. Now, the formula for a straight line looks like this. Y equals A plus BX. Now, some books use that formula, but other books use this formula. Y equals MX plus B. Now, this is like just Spanish and English. These are two different ways of saying the same thing. Y would be total cost. The B and the M would be equal. The X and the X would be equal, and the A and the B would be the equivalent. So you just get used to using one formula, or you get used to using the other formula. They both work. But this author, well, accountants generally use this one. But I think this other one is gaining in popularity in the textbook world. Y equals mx plus b. Nevertheless, the accounting culture uses this, and so I'm going to use that. Now, y equals total costs. A. In algebra, A was called the y-intercept. But in accounting, it's called total fixed costs. So this is the y-axis and this is the x-axis. And so wherever this line crosses the y-intercept, that's the total fixed costs of your factory or business. Now, B is the variable costs, not total variable cost, but it's the variable cost per unit. Now, that was called, I should have written that here, slope. In algebra, we call that variable slope, but in accounting, we call that variable the variable cost per unit. Now, X in algebra is called quantity, and we could still call it quantity in accounting, but the textbook is going to call it volume. An increase in volume is an increase in quantity. Now, if you know any three of these variables, you can predict the fourth variable, and that's what algebra does. Find the value of an unknown variable. Now, Now, here's something else to review from a previous exercise. This curve right here would be the total cost curve, and this curve here would be called the revenue curve. And if that point right there is the break-even point. So these are two straight lines. Over here, I've given you the formulas for the total cost curve. Now, I want to adjust this a little bit to give you the formula for the revenue curve. In the revenue curve, Y would not be called total cost. It would be called, I should say, or it could be called revenue. So that curve is the revenue curve, and the other curve is the total cost curve. In the revenue curve, you have to add one thing to this equation, plus P. Y equals A plus BX plus P. That would be profit, because revenue includes your costs and your profit. And something else. When Y is your revenue, revenue could be further broken down into S times X. Now, X we know is the volume, and S is the sales price per unit. You know, the sales price per unit is the cost of each unit you produce in your factory. It's not a total revenue, it's a per unit revenue. All right, so in review then, here's the two formulas. Y equals A plus BX, or SX equals A plus BX plus P. The first formula is the total cost formula, and this is the revenue formula. I'm going to erase this now, and I'm going to use these formulas. Well, actually, I'll just use this formula in this. No. I'll use the second formula to solve the questions of this exercise. But this is a really great formula. This one formula can get you through so much managerial accounting. Now, the chapter teaches you some shortcuts, but those shortcuts end up being a nightmare in the long run. If you just learn this formula, you can really it really helps you to not get lost in all of this. So let me erase everything and make some more space here. I will take this out, this out. I will leave that. Now I'm going to use the formula S times X equals A plus BX plus P. All right, now let's read the question here. For the current year, fixed costs are $372,600. A is the fixed costs. So let's insert $372,600 for A. Unit variable cost is 48. So the unit variable cost is B, 48. The unit selling price is 71. So S is 71. And then it says compute the break-even sales. Units. What is units? X. Another word for X is units. So what are they asking? Compute the units. Solve for X. Break even. Well, break even is when profits are 0. So whenever they say solve for break even units, set your profit equal to 0 and then solve for X. I'm not going to actually go through the motions of doing that. But let's read letter B. I'll change the color here. Letter B says, compute the sales units required to realize a profit of 85. So if that's 85, 100 instead of 0, then solve for X. It's a prerequisite of the class for you to know how to solve for X. That's pre-algebra. So I'll just leave it at that. Well, maybe I'll do one of these for you. So if you subtract 48x from both sides, you get 23x equals 372,600 plus 85,100. So 372,600, 85,100 plus, so I can add these together and they come out to 700, and then divide both sides by 23, and that will give you x equals whatever it is. Okay, so that's a review of your algebra. We're going to use this equation right there. I'll do another exercise, maybe a more complicated exercise, just so you can get the hang of this, because it's really useful, it really is. Okay, there you go.